Section 6, patterns of numbers. Okay? Here's the pattern. 2, 4, 6, 8. What's the pattern? What comes next? Who do we appreciate? All right. So, really bad joke. Anyway, so as we're looking at this, we're going to try to figure out what our problems are going to be in terms of what our pattern is. And so most of what we're doing today is picking up patterns, deducing patterns, and figuring out, given a formula, how to make a pattern off of that formula. I tried to give you the general formula in the middle for an arithmetic sequence. Now that's a little bit different than you ever said it before, but this word right here, normally we've talked about it as the word arithmetic. When we're talking about a pattern of numbers, it's pronounced arithmetic in terms of its pronunciation. It's just a little bit different. So, an arithmetic sequence is something like that we just started with. 2, 4, 6, 8, and truly, what is the next two numbers? 10 and what? Why are those the next two numbers? Okay, because our pattern says we're adding 2. All right, now, in mathematical terms, we call that a common difference. The difference between each numbers is 2. Now, how do you find that common difference? Really, really simple. The following must be true for it to work. What's 4 minus 2? 2. What's 6 minus 4?
2.
Okay. 8 minus 6?
2.
So, all of those cases must be true for it to be an arithmetic sequence. The second minus the first, or the third minus the second, or the fourth minus the third. If those are true, it's an arithmetic sequence. And that's what we're going to try to identify today. So let's look down here at these patterns. They may be arithmetic sequences. They may not be. But let's think through it. 1, 4, 7, and 10. Raise your hand. Don't say it. Raise your hand if you know what the arithmetic pattern is. Okay? I got 5 or 6 hands up. Scotty. It is. It's add 3. Okay? Notice, if you add 3 between each one, does the pattern hold? So in this one, it has a common difference. And so 13 and 16 become our next two numbers. That is an example of an arithmetic sequence. Look at the next one. Different pattern. Raise your hand if you think you know the next number or the pattern. John.
Is it like adding an odd number?
Explain. When you say adding an odd number, what do you mean?
So it's like plus 3, then plus 5, then plus 7.
Let's see, does that work? Plus 3 is 4, plus 5 is 9, plus 7 is 16, so the next one will be plus 9, so it makes it what number? 25, plus, does that look right? Okay, Nate, question?
Oh, no, I was kind of going with it. Let's go to the next one.
We'll get there in a sec, but not yet. As we're looking here, that's all fine and dandy, so you could say the sixth term is 36, right? Now, listen to my wording, and I'm going to show you an easier way to pick up on this. The first term is 1. The second term is 4. The third term is 9. The fourth term is 16. The fifth term is 25. The sixth term is 36. Can anyone tell me the ninth term? 81. The 11th term, 121. Does anyone see the pattern that I'm kind of saying? The 7th term, 49. You got it. Don't say it. The 8th term, somebody. Don't say it.
17.
No. Zach? 64. He's got it. Zach, the 10th term. 100. How did he get that so quick? Scotty, what's the pattern? Multiplied by itself. What's 1 times 1? 2 times 2. 3 times 3. So the patterns are multiplied by itself. We call that a squared pattern. Okay? X squared, that's the pattern. Here the pattern was add 3. Nice pickup, Zach and Scotty. All right, next pattern. 8 to 14, 14 to 20, 20 to 26. Nate, you said you had this before.
Yeah, if I already wrote them down, it's basically you're adding 6.
Okay, so he says we add 6. So Nate, what's my next two numbers?
Yeah, 32 and 38.
Okay, So this is a combination. Once again, we're adding a consistent number, and so that is called a arithmetic sequence. All right, let's look at example 4. 2 minus 4, positive 8, negative 16. What's happening to the pluses and minuses each time, John?
They're being divided by negative
Multiplied by negative 2. Okay, so over here to the side, let's write multiplied by negative 2. So John, can you give me my next 2?
Negative 32.
Positive 32.
And negative 64.
Nice pickup. All right, now let's circle the 2 of these. Let's circle number 1. Let's circle number 3. Because by circling them, what I'm saying is these 2 specifically are examples of arithmetic sequences. When you're adding or subtracting numbers, that's an arithmetic sequences. 2 and 4 are kind of just unique other ones. Important to recognize, but not extremely in terms of what we're doing today. All right, part 2. Down here at the bottom. All of the following 3 patterns are arithmetic sequences, which means they have a common increase or a common decrease. To find that common increase or common decrease, we're going to do the following. We're going to subtract the first term from the second term. So think with me. What is 21 minus 8? 13. So D is the variable that we use for the common difference, little d. And let's just check it. What's 34 minus 21? 13. And what is 47 minus 34? Okay? All of those must be true. I don't say it's the difference, I say it's the what difference? Common. In other words, it's the same each time. That's what common means. Okay? They're all the same. Okay, 13, 13, 13. So circle D equals 13. That is our common difference. Let's look at the next one. A little harder here. Negative 10 minus negative 6. How do I minus a minus?
You make it a positive.
Okay, so we make that a plus. So I get negative 10 plus 6 is negative 4. Okay, so D equals negative 4. Let's check another one. I'm going to check the 18 one. Negative 18 minus negative 14. Minus a minus becomes a plus. Is it negative 4 again? Okay, so that's just a little check to make sure that you have the common difference. Harder with a bunch of negatives. I wanted to throw that in there, Hunter, just to show you what to do. Number 7, your turn. Go ahead. Do it on your own. If you need to look up, that's fine.
I don't even have to do calculations.
Common difference is 12. All right, so back up here to the top. Look at this formula now. As we look at our formula, right here, the back number, right there, that's the common difference. So whatever the number is outside that parentheses there, that's the number that's going to be how much you go up or go down. Say this back number, D, was negative 3 in parentheses. Now you're not going up, now you're doing what each time? You're going down because it would be a negative. If that was a positive 10, each time you go up by 10. So it depends what you have in terms of up or down. Also notice here, see this number up in front here? That always represents our first term of the sequence. So 1 or 8, those numbers would have been up here in our equation. So I just want to try to show you and identify some of those ideas for you. All right, let's flip it over.